This is section 214. We're going to take a look at the average rate of change. And in this lesson, we're going to find the average rate of change and find the slope of the secant line. Now, if you notice in this first example here, the slope is constant. Now, we can only use the phrase slope essentially when we want to refer to a line. Now, if I were to create a graph that's not a line, what if I wanted to find the quote-unquote slope between these 2 points on a graph? Now, instead of calling it slope, we call that the average rate of change. Now, just understand that essentially the average rate of change and the slope are the same thing. They're both y2 minus y1 over x2 minus x1. It's just going to be that the average rate of change looks a little bit more fancy. So if you notice, instead of calling it x1, I call it a. Instead of it calling it x2, I call it b. Well, if I plug in a into my function, you get your y value, and so that's y1. If I plug in b into my function, you get your y value, and so that's going to be y2. So instead of saying y2 minus y1 over x2 minus x1, we say f of b minus f of a over b minus a. That's the same thing as y2 minus y1 over x2 minus x1. They're the same thing. We're just redefining it. Now, if I wanted to then create a line, like drawn in this graph, if we see this line here, that line that's created between those 2 points, we call that the secant line. And so this rise over run, we call that the slope of the secant line. Now notice I can use the word slope because it's referring to a secant line. So just be a little careful with that. Average rate of change on functions that are not lines, but it's quote-unquote the slope. You can use the word slope when referencing a linear function. Now let's just think of this hypothetical situation, right? The reason why the average rate of change is nice is, let's just say hypothetically you travel for 2 hours and you go 100 miles. Well, the average speed is going to be 100 miles over those 2 hours. It's 50 miles per hour. But when you drive, who says you're actually driving the constant speed? You might be driving 25 and then speeding up to 65 and then slowing down and then speeding up again and then slowing down. So your speedometer measures the instantaneous speed, but it's not giving us the average speed. Now that instantaneous speed, that instantaneous rate of change, that's going to be a central theme that we're going to talk about in calculus. So let's find the average rate of change. Now this interval that I give you, this is the interval a and b. So this is your x1 and this is your y1. Well, if these are my points, -1 something, 1 something, well, I have to plug them in to find my y. Well, if I plug in 1, or -1, -1 cubed is -1. If I plug in 1, 1 cubed is +1. So f of b minus f of a over b minus a, this is y2 minus y1 over x2 minus x1. So that's going to be 1 minus -1 over 1 minus -1. It's 2 over 2, which the average rate of change is going to be 1. For this next one, same thing. F of b minus f of a all over b minus a. Well, these are my x values. So for my first point, I have -2. I still have to find my y. +2, I still have to find my y. So if I plug in -2, -2 cubed is -8. If I plug in +2, 2 cubed is 8. So now we can plug it into the formula. F of b, right? This is b. This is your f of b, or your x1, or sorry, x2 and y2. So y2 minus y1 over x2 minus x1. So that's going to be 16 over 4, and that's going to be 4. So my average rate of change over that interval is going to be 4. And so the idea is, if I were to kind of sketch that graph, it's saying that these points, if I were to think of it as a line that goes through them, the slope of that line is going to be 4. So now what if I wanted to find the equation of the secant line that passes through those given intervals? So if I want to find the secant line, okay, so we need to think about what are the two elements that I need to create a line. I need a point and I need a slope. Okay, well the slope of the secant line is the average rate of change. So if I looked at the previous example, I found that the average rate of change is 4. So that's my slope. But now I need a point. So the slope of the secant line, I'll just write like that. But now I need a point. Well, how did I find the points? I was given the x values. Well, I plugged in -2. If I plugged in -2, it gave me -8. So same thing here. If I plug in -2, -2 cubed is going to be -8. So there's my point. So now y minus y1 equals my m times x minus x1. So this right here is going to be the equation of the secant line that passes through that given interval. Now we're going to close this lesson by re-examining the difference quotient. Remember the f of x plus h minus f of x all over h. Now the way that it's created is actually using the average rate of change over the interval x and x plus h. So if this was my a and this is my b, here's f of b minus f of a over b minus a. Well, the x's ended up canceling out, and so we're left with our difference quotient. Now there's a bit of nuance with this, and that nuance is discussed in calculus. So just know, at least going forward, that the way that this equation was created was through the average rate of change. And the interval was x and x plus h. So what did we learn today? We talked about the average rate of change and how it's the slope of the secant line. So what is the average rate of change? It's essentially the same thing as the slope, but we use the fancy equation f of b minus f of a all over b minus a. And how would I find the slope of the secant line? You would use the average rate of change formula, and that slope that's given is going to be the slope of the secant line. This does conclude our lesson. If you have any other questions, please leave them in the comments.